Hello everyone, my name is Tianze Zhang, and today I will do a presentation about a data science case study, Internet of Things. What is IoT? Basically, the Internet of Things, or IoT, refers to the physical devices that can be already connected to the Internet. These physical devices that have been connected to the Internet are collecting and sharing data about the way that this device is being used, as well as the environment around the users. Also, these devices that connected to the Internet can communicate with each other to exchange information. The development of wireless networks also contributes a lot to enable the devices to communicate automatically when they are in a wireless network area without a human being involved. Some examples of IoT devices are divided into two categories: consumer application and industrial application. For consumer application, we can have a door with a sensor that will sense the owner's presence when the owner approaches it and unlocks it itself automatically. When the owner leaves the home and closes the door, the sensor will send this information to all the electronic devices that have been connected into the network in the house. So these devices will go into energy preservation mode automatically. Another example for consumer application is a smartwatch. Generally, a smartwatch can monitor our heart rate and some other health index regularly. If there's any irregularity happens, it will send a notice to the owner's doctor or the closest hospital. The example for industrial application is smart cars. Actually, smart cars have already been developed by several companies. One of the possible functions for smart cars is self-driving. So this function will have a big impact on a number of industries. According to some researchers, self-driving cars can reduce the possibility of car accidents by up to 90%, which saves huge amounts of money. Next is hypercycle of IoT. Basically, the development period for IoT applications is between 5 to 10 years. For example, in this picture, we can see mobile health monitoring, machine-to-machine communication services, connected home. This means most of IoT applications are still in development and will reach their peaks in the next few years. Next part is about the relationship between data science and IoT. The way that IoT change big data is first is quality data. We need to extract the quality data collected by IoT devices. Not all the data is useful. We need to know what kind of data we want from the data collected by IoT devices. Second is the traditional database is not suitable for IoT for the data collected by IoT devices, because the data collected by IoT devices is unstructured, which means it cannot be easily stored into a traditional database management system with tables and relations. So data scientists can use NoSQL database to organize the data in their own ways to make the data usable. Next way that IoT change big data is because most of data collected by IoT applications is raw and unstandardized. So special analytic tools are essential to transform and process this data. Challenges for implementing data science for IoT. The first challenge is how to make sure the devices from different manufacturers can talk to each other, because they all have different standards. So we need to make sure that different IoT devices can communicate with each other and exchange information with each other. Also, Internet of Things will capture every part of customers' information, include sensitive information. So privacy is another big issue. No matter what kinds of another challenge is no matter what kind of devices, they always need to face their own security challenges. With more and more devices coming into the internet, the security challenges will go into a different level. The main issue is that parts of our lives could be penetrated, which we don't expect it to be vulnerable. For example, what would happen if a car is hacked and the customer is still driving it? Every day without noticing it. Some advantages like machine-to-machine communication, automation and control, real-time information, monitoring, saving money, increasing efficiency, and a better quality of life. Disadvantages about the is like compatibility for monitoring devices, complexity to build the IoT network. Any bug in the network would have serious consequences. Information privacy and security, safety, and employment issue due to automation, also less controlled by technology. The last part is analysis for an real example of IoT application. This application is presented by Daniel Dean. It's a senior data scientist at Microsoft in December 2015. So this application is it's an application to model machine failure. So, it's a predictive maintenance application. For example, people could think of this application as when they need to change oil in their cars, for example. The streaming data collected by sensors could give much more information about our cars, and we can predict not only the time for oil change, but also the failure time for other parts of the car. Moreover, predictive maintenance also includes root cause analysis, which gives the reason why something fails. The business model involved in predictive maintenance application is machine learning. Their team used publicly available data from NASA that is related to engine run to failure to train a machine learning model. Based on the data set, they built the machine learning model to learn the relationship between all the sensor values. For the data that has been chosen for machine learning, it is important to make sure the data is what we need. Also, the accuracy of data and enough amount of data are two key factors for the success of prediction. Also, they use different modeling techniques like binary classification, multi-class classification, and anomaly detection. For binary classification, it's generally used for 1 or 0 prediction. For example, predict if a failure will happen in a certain period. For multi-class classification, for example, if the engine will fail in next 30 days or 20 days or 10 days and so forth. For anomaly detection, this is more about a reminder that gives an alert when something changed. There is no actual failure, but some value will go above a certain threshold, and the model also needs to learn the new threshold for that indicator. That's all for my